dive the agentic application stuff. So because of the hands-on workshop, we don't have agentic AI application hands-on yet. So that's why we have a separate talk today. So as you can see, James and I, we are trying to play the role AI today. You can see our like a face somewhere in the slide. And then, so this is a more like a how to get started develop agent application with Java, not Python, not JavaScript, not any other program language. And then you probably know there are many kind of agentic definition right now. So we're gonna try to start from beginning and then not just the end, and then starting from your local and more like an in-order developer experience, and then we're gonna go to cloud. How do you make some agent application template and share your developer team? That's our goal today. So my name is Daniel. I'm from Red Hat as a developer advocate as well as a Java champion. And then based on Boston, a couple hours flight, and then multiple times in Devnexus, and then super happy to be here again to see a lot of people here. And my colleague James here.
Yes, thank you, Daniel. I run products and technical marketing for Red Hat's runtimes, which includes things like Quarkus and Spring and Node and our traditional Java EE runtimes as well, like JBoss.
Sure, thank you. And then here's our social handler, so you can reach out to us anytime after this Devnexus if you have any question around the Java, Quarkus, LangChain4j, and MCP, and then any other Red Hat products and technology. And you can also stop by anytime the Red Hat was in from there, and then we are happy to address your questions. So before we dive into the like a little bit hands-on demo, we're going to really bit talk about like some fundamental thing. So everybody maybe heard about agents. So I've got a quick question. So how many people have some experience with AI application development with Java? Nice.
Not Java, but.
Not Java, okay. And then AI, okay. And then how many of them you actually use Quarkus buffer or not? 0? Okay. No surprise.
There's one. A couple.
So, okay. But so are you guys all Java developer except for you?
No, I am also Java developer.
Okay.
But all the AI application side
Yeah.
of it is either Python
Yeah.
or .NET.
That's nice. Okay. So
I don't consider myself like language.
okay.
Specific. I can
Okay. Sounds good.
GitHub Copilot is there to help. So.
Okay. That's awesome. Yeah. Thanks for sharing. Excellent. So yeah, that's really helpful for us to understand the developers from background. So agent is you can define in many million different ways. So basically, agent is some kind of program, could be like some of the system platform, which have like autonomous capability. Just imagine that you have your personal, unique, private assistant, just like a human being. If you watch any like a Marvel movie, there are Iron Man and there are Jarvis is like a persistent, personal AI assistant, just like your agent. So that is some concept of an agent, rather than you need to explicitly ask or program, you need to do ABC, that's not agent. So whatever you ask, like a natural language, agent will decide whatever they need, whatever they decide, and then they actually find some perfect right solution and then back to you, like an end user. And then there are interesting another definition from Anthropic, which is one of some very famous thing right now for AI industry. They actually invented the MCP, Model Context Protocol, as well. So they actually distinguish two different things when they define agent, because a lot of people confuse between workflow and agent itself. So workflow, you can actually create some AI application with some fixed paths. For example, so I'm gonna I have like some AI application. First application, so I'm gonna prompt or input some, ask, hey, I need to create some beautiful romantic story. That is my ask, like as a user prompt. And first agent writing some nice article or blog some stuff. And the second agent try to improve the first writing more like a professional way or more like a universal student way, whatever you want. And the last thing is the last agent try to correct what some literacy, vocabulary, or and so on, like a grammar thing. But this is you can define and develop multiple agents as like a pragmatically way, and there are fixed paths. So first thing is you're gonna do that. Or example, you're gonna go to like a Google search or Google Maps or like another like a first LLM, ChatGPT, or like a DeepSeek. You can define what the application, AI application needs to do. That is a workflow. An agent is more like a have an autonomous capability. You don't need to ask agent what needed to do first or the next step. Agent and LLM will decide the workflow by themselves, and then they maybe ask LLM more than 10 times or just one time, decide whatever they want, and then until they will get right answer back to the end user, just like for you. So there are many use cases, like an example, what cases you're gonna use agent. So pretty much you probably heard about that before, like automating some task, repeatable. Rather than you're gonna use, it could be like a writing code, some of the specific code, or some of the job. Okay, I have like a cadence call, like some routinely, I have a meeting with my customer, with my team, and then I need to set up appointment, like some kind of dinner place or even meeting place. I'm going to routinely do, but sometimes I need to checking another information from my team member or some venue availability. So it could be done by agent. Just as I said earlier, so agent should be your like a personal assistant and unique, rather than like a universally general some kind of AI application. You can also personalize user experience. James will really talk about some matched agentic application example too. For example, personalized user experience, you could have like a iPhone Siri, or you can have Amazon, the Alexa at home. This is just some kind of like a personalized agent as well. You can ask, hey, I need to change some of my temperature of my master room, and I need to turn it on, my light under my second room. This is just some kind of agent use case as well. So what about the agentic application? It's fundamentally implement your specific agent. James, we're going to talk about a little bit more detail here.
Yeah, I think I need to get in frame for the recording, so let me take your spot. So Dan gave you kind of an overview of what agents, what the concepts are. I'm going to get a little bit more detail into the apps, and I'll show you the first demo, and then Daniel will show you the really cool demo. So you can think of, this is a diagram that everyone has probably seen. You send a prompt to an LLM, you get a response. So agents or agentic applications essentially give that LLM more superpowers, right? You have the ability to query, say, a web search. You have the ability to call other tools, talking to a calendar or talking to a machine control plane. And also, more importantly, it has the ability to do long-term memory. So remembering facts, characteristics, relationships, various things about its environment so that it can use that in its future reasoning. So the power here is that all these things on the bottom can be customized, right? So depending on your use case and depending on the capabilities that you want your agent to have, you can customize those and give that LLM essentially superpowers. So here's some examples. Daniel talked about a couple, things like Siri as a personal assistant, customer support, automated customer support for classifying tickets and routing requests, assigning engineers to fix things like that, smart home systems. Any of you may have a smart thermostat in your home or automated lighting, and this is a fantastic use case for an agentic application where it needs to reason about its current environment, learn the history, your preferences, your behaviors, and apply those to whatever the system that you want to control is. Robotics, similar. Things like, and this might not necessarily be generative AI, but more predictive AI, traditional ML AI, making decisions autonomously about when to turn a machine off, when the vibration level reaches some threshold, things like that, so it doesn't explode. Also, there's more examples in the financial space. We've been trading securities for a long, long time, and it's always been humans. And a lot of the decisions they make can be automated and have been automated and are being automated today. And then also content creation tools, and that goes beyond just simple, generating web content. It's things like creating new pictures based on textual descriptions, or maybe giving an audio description of an image and having it generate that. So more complex tasks that can be automated, or that can be autonomously done through an agentic application when it's given the right resources and tools and capabilities. So this is the key difference. And this is one of the things that Hans and Henrik talked about at JFocus, I think it was back in February. When should you use agentic applications? What are the good use cases? And there's a range of types of applications in this particular axis. On the far left, you have the most predictable application, things like applications to tell me what's my bank balance, right? You don't need agents for that. That's a database lookup, right? It's completely predictable. It can be automated without the use of LLMs or agentic architectures. Not a great use case for agentic applications. And then on the far right is the completely unpredictable nature of a use case. In this case, an example is having a one-on-one with your manager, right? You're not going to send an LLM to have a one-on-one with your manager. You're going to do it yourself. You might use an LLM to maybe get some ideas, but you're not going to automate that process. So that's completely unpredictable and also not a good use case. The sweet spot is in the middle, and this is where there are human elements to the task, but it also has a bit of the characteristic is such that an LLM can do a good job at creating things. So where there's some creativity needed. So for example, classifying a support ticket. Support tickets are generally written by humans, and so LLMs are really good at reasoning based on those inputs, and then can go off and classify a ticket, assign an engineer, or route an email, or things like that. Also, writing a sales report, right? That takes a little bit more creativity, but there's also a human element to that. And so you might use an agentic application to give it some input, give it some tools, go off and look at Salesforce, or go off and look at some other data source to build that sales report, and then kind of iterate with an agentic application with a human in that loop to build that thing. So this is the sweet spot for agentic applications. Okay, when designing agentic applications, there are a number of I wouldn't say well-known because this is a new space, but emerging architectures that make a lot of sense. So for example, the first one, reflection. This is one where you use an LLM you tell the LLM to reason about and reflect on its results. So it iterates itself over and over again. You can actually improve the quality of the output from an LLM using a single LLM, but allowing it to reflect on what it has done, go back, iterate, and improve things. A second one is tool use, and this is the one we'll be showing mainly today. This is where you're giving an LLM a set of tools that it can accomplish tasks with, and then asking it to plan and reason and execute on that task and give you the result. A planning design pattern is one where it's a multi-step complex task is given, and a reasonably well-tuned LLM can plan the steps it's going to take and then execute on those tasks. And then you get into multi-agent collaboration where you have multiple agents or multiple LLMs. I mean, they can be constructed in various different ways. So you can have peer-to-peer where you have essentially two agents that are they have specialized capabilities, specialized skills. So maybe one's really good at writing poetry, maybe one's really good at fixing grammatical errors, and you can kind of combine those into a multi-agent collaboration scenario and architecture. And then you get even more complex things like hierarchical, where you can design agents to be like a manager-employee relationship, where it delegates tasks and the employee kind of gives advice and gives information, and then managers make decisions. So there's a number of different ways that you can construct these things. It really depends on the use case and the outcome that you're looking for. There's lots of frameworks. I know we heard .NET. That's probably the first time I've heard about .NET for AI applications, which is fantastic. We have the ones listed here, and you've probably heard of some of these, if not all of them. There's probably more that we're missing here. In fact, I know there's more we're missing here, and there's more each and every day. The challenge is those were not designed for Java developers. So things like Pydantic AI obviously is Python, LangChain, LangGraph, all these are primarily designed for Python developers. Now there are some other frameworks for Java, things like LangChain 4j, and probably frameworks for .NET that I'm not currently aware of, but I'm sure they exist, and there's frameworks for other languages as well. But primarily, it's a Python world out there, so as Java developers, what are we gonna do? So we're gonna show you today how to do this with Quarkus. Quarkus is a Java framework, has lots of interesting developer productivity capabilities, and now we also have an integration with LangChain 4j, as well as a number of other capabilities surrounding that in that ecosystem to really make it easy and fun to build applications. And so that takes us to what we're going to use today with LangChain 4j, which is a relatively new project from Anthropic called Model Context Protocol. And so Daniel's going to give you a bit of information about that, and then we'll switch over to the demo.
Yeah, thanks, James. So this is for Java developers. So Quarkus, I heard you never ever heard about it. Well, maybe heard about it, but never ever experienced it. Maybe your company or organization doesn't allow you to use that in daily job. We totally understand that. So you probably heard about the LangChain 4j, which is like some new Java framework to communicate with multiple LLMs. And then LangChain 4j is just open source, and then you can use the LangChain 4j as purely, and then develop any kind of stuff. For example, so back in the day, you can implement like a socket networking application with Java. You can implement a bunch of stuff by manually, so which is not good way. So that's why new like a wrapping class and API or some of the libraries came out, and you can easily use that. No, you're not gonna implement like a networking from like a low level. So that's like a Quarkus integral LangChain 4j to accelerate developer productivity. You can pretty much easier like a CDI injection and like a polymerize and then like a wrapping some of the stuff. So that's Quarkus integrate LangChain 4j for developer. But you can still use LangChain 4j as a pure and then your plain Java, even Spring as well. So Spring provides two different ways, Spring AI and Spring with the LangChain 4j. So it's a totally different stuff, by the way. And then once again, there are model context protocol. We're gonna combine three great things into agentic AI implementation. So why model context protocol? So as you mentioned earlier, so let's say you have like your laptop as your working or desktop, whatever you have, and then you have multiple external devices. For example, like a flash driver or the audio some devices, among others. How to plug in your laptop as external devices? You probably using like a HDMI or like probably some RGB stuff, pretty old case, or USB-A, USB-C. Now everybody most likely using USB-C port, which is so convenient. You can even plug in your battery. You can plug in any flash driver. So doesn't matter what kind of external devices, you can use only one standard port that can allow you just plug in, plug out the even data transaction or power outlet. It's just so convenient. So we need to something like that in LLM stuff when you develop like agentic application, because there are more than millions different LLM. When you go to Hugging Face, you can find more than 2 million models. And then maybe, there are so many, but it's really hard which one would be perfect for me. And what about the application stuff? You have a multiple Java framework or even Python, even JavaScript and any other .NET stuff. So this is hilarious. In the left-hand side, there are so many application framework platform, and the right-hand side, this is just millions different model. So that's why the model context protocol in somewhere middleware between that both sides, and then it's like communicate with the standard way. So that's the MCP stuff. And then one more thing, as a Java developer, okay, I'm going to go to MCP, like some documentation. Oh, there are many good example code snippet, but maybe not super familiar with my developer experience. For example, if you are a Spring developer or like a old-time like a EJB developer.
I don't know why you keep looking at me when you talk about the old stuff.
Yeah, anyway, so you probably with some like you're familiar with like a tools, API, wrapping class, or abstraction, something like that. So Quarkus and MCP extension, like some Maven library, you can say that it gives some more developer-friendly practices how to develop MCP stuff. Basically, you can build the custom MCP server and client with the Java application, and it automatically generates the tool like MCP server using like sub process. So James is going to show a quick demo for that. So you're going to add some command line like a node package manager, npm stuff, and just a configuration model in your application property or YAML file. It automatically start using that command line, add some sub process in your local machine to serve MCP server. You cannot find any line of MCP specific code in the Quarkus project. So that's a really good point to accelerate developer productivity. You don't need to write it down all like some complicated MCP code from the manual stuff. And you can also always tracing down your what happened inside the MCP server and client for logging capability. The Quarkus basically override the default MCP log handler, which conveniently you can actually expose that log stuff using CDIB, and you can expose automatically like a Quarkus logging stack, and like we can say a GTM, the logging, tracing, visualization with Grafana and Tempo, Rocky, and then Prometheus for metrics data. We're going to show that thing as well in the demo, and then you're going to provide using standard IO or like a HTTP with some security capability, like authentication, authorization, like based on RBAC control. But that's not the end. The more important thing is the Quarkus provides a bunch of the developer productivity feature James mentioned earlier. So there are like a dev services. We're going to use that today, and then like a native compilation and the dev UI, and then for AI specific application, you can set up the guardrails, like a validation check. Before you send a message to LLM, and then before you send it back to user, so between some validation for like a PII or some sensitive information or some compliance issue stuff. And then on the RAG, well, there are many kind of fundamentally developer productivity related feature you can natively use with the MCP, the implementation as well. So this is like a 10,000 feet demo architecture. We're going to a little bit more deep dive and complex the architecture in the application demo stuff. But basically, here is your like a host, MCP host could be ID tools, could be like a cloud desktop, or could be your AI tools, library, and the client, and then client application. So we're going to use Quarkus today. And then there are models. You can use one model, you can have multi-models. We're going to use like a GPT Mini, right? Yeah, that model. And then basically there are server. You can, the Quarkus, as I mentioned earlier, Quarkus automatically create and running in the server processor in the laptop for the demo case. And then you have a multiple like external services for process your user prompt. So there are many kind of integration and open source ecosystem actually keep integrate MCP stuff with like many external services. We're gonna take some of the from there. Like we're gonna use a Brave Search or Google Maps, Slack, file system, time, and then memory. There are a lot of external services now available as like a native integration with the MCP, the protocol right now. So I'm gonna hand it over to James to the demo.
Okay.
Right?
Yes, thanks, Dan. So yeah, I'm going to show you a brief demo. So what I have, and before I say this, I will say agents are like, I think of them as like children. right? There's the kids in school, there's smart kids and there's not so smart kids. So depending on the LLM you're using, your results may vary. Using really well reasoning LLMs can produce better results. We're using GPT-4o Mini. So there are larger and more capable models out there. We just don't have enough credit card space to run them today. But so what I've done is I've created a simple Quarkus application. And essentially the message here is that the combination of Quarkus plus LangChain4j plus MCP gives you the superpower to build agentic applications very easily. So the first thing I'll just kind of showcase is the LangChain4j interface. So with Quarkus and LangChain4j, it's very easy to communicate with LLMs. You basically just annotate an interface here. You give it the system message in regular English text, and then you have an interface here to chat with that. So that's what I have here. I then have a WebSocket, which is going to be taking requests from my front end and then making a call back to that bot here. And now I have a front end. I will freely admit that I am a terrible front end developer. So what you see was mostly generated from an LLM, but in my front end application will then make that WebSocket connection. Then I'll be able to do chat with this application. So as a Quarkus application, the configuration lives in this application.properties files, which should look somewhat familiar. It's just a bunch of Java properties. And this is where MCP integration begins. So in our case, we're only using the tools capability of MCP. MCP also has the capability to provide prompt templates for different services. It has the ability to expose resources. So for example, the Google Drive MCP server has a tool called search. When you search and find a document in your Google Drive, then you can use that resource endpoint to actually download the contents of that document or whatever you found in your search. So we're only going to be using the tools capability here today. And so the cool thing here is that all you need to do is add 2 lines. Actually, there's 3 lines. There's an API key that you need to add for certain services. Things like Brave search. So we have a declaration here of the transport type, which would be standard IO. And then we have a command to start up the Brave search MCP server. So this is running locally, or will be running locally as soon as I start the application. You can also deploy MCP servers remotely on clusters in Kubernetes and then connect to it through HTTP or HTTPS with certificates and keys to secure that connection, which makes it easy to scale this out. But for demo purposes, this will be running locally. So I have 5 tools here. I actually have 6, but I'm gonna add one later. So we have a tool for interacting with the file system. And by the way, these are all kind of standard MCP tools that are blessed in the MCP ecosystem. There's many, many others. There's hundreds, maybe thousands. So we have a memory tool, which allows that long-term memory, which you'll see. We have a Google Maps tool for searching Google Maps and providing driving directions and things like that. And then we also have our Brave search here. I'm going to add Slack later, and you'll see why I'm going to do this later. So let me just go ahead and start up the application. So it's pretty easy. You can just do Maven.
Can you open the activity monitor, the npm processor? You don't have any running processor right now, and after you run that, and then it will automatically show the process. Yeah.
Sure. Okay. So let me just start it up, and you'll see it won't actually start up the MCP services until I make that first query. But I'll start this up. I'm starting this Quarkus application in dev mode, which means I also get a dev UI, which you'll see in a bit. But if I just open the web front end for this application, this is my fancy application, my personal assistant dashboard, with a chat bot. And that's the chat that's going to be connected via WebSockets back to my LLM. So let me just go ahead and ask, and I have some pre-created prompts here that I'm just going to copy and paste in. It's a little bit of a prompt to asking my agent to find a good lunch place for me and my team next Wednesday at 12 o'clock. And I'll just paste it in here and you'll see it. So find a good restaurant that meets the team's dietary needs, invite the lunch meeting at 12 o'clock, post to Slack, include the name of the description, give me driving directions from Georgia World Congress Center, and create a calendar entry for me. So you can see in the background here a bunch of stuff's happening. And so it found Oku. Has anyone been to Oku in Atlanta?
Anyone the local here?
Yeah, there's any local people here.
Someone
it's a
actually
good restaurant.
confirmed.
I don't know. So anyways, it gave me the driving directions, gave me the current date, current time, and it knows the current time, but it didn't do anything on Slack. Actually, I need to open Slack. Slack doesn't work because I haven't given it that capability, but let's go ahead and ask it a few more things while I'm getting this Slack up and running here. So let me get my, where is it? It's here. So why didn't you post this to Slack? We'll just kind of challenge it. Currently doesn't have the capability. All right, we'll add that later. Another interesting thing to kind of showcase the memory capabilities of my Agentic application here. What were the things that you remembered about each person on the team? This is kind of drives the reasoning about why it shows things. So I see me. This data comes from previous interactions with this bot. So I was able to use that long-term memory to store where I live, what my diet is, and so forth. And Daniel, of course, in the same thing. So it kind of used that to reason about what type of restaurant to find. And so that's why it was searching for and found a gluten-free, or a restaurant that provides gluten-free options and is also nearby. And also what time to do it. But again, it didn't post anything to Slack. So what I want to do is show you how easy it is to add a new MCP server. And then Daniel's going to show you how you can productize and operationalize that capability with things like Backstage. So I'm just going to comment this, or bring this definition in of Slack to give it new superpowers, if I can type properly here. So I'll uncomment that. I'm also going to uncomment the ability to do automatic telemetry. So Quarkus has built-in capability for open telemetry, and both LangChain4j and the Quarkus MCP extension also expose metrics, export metrics and telemetry about the application, as well as tracing information. So things like spans and traces to see the chain of calls. Because when I made that first request, you may not have noticed, but in the background you saw a bunch of stuff scrolling by. It was basically having a conversation with the LLM. The LLM was asking my application to call this tool, give me the results, call this tool, give me the results, call this tool, give me the results. In fact, if I go back to my application, well, I can't now because I've...
Yeah, you might be aware that the backend side, the James terminal window to where the Quarkus is running on there, you probably see there are many logs is super fast going on when he asks some prompt. So that's why you probably need to observability, like some Grafana, the visualization, trace down what kind of happening. So because it's a traditional AI application, you're gonna set A, you're gonna call to model A, and then back to the database, and then back to the some messaging server, and then back to your end user. But you don't need to do anymore with the Agentic application. But Agentic and LLM will decide and change and update the prompt autonomously. So that's why you might wonder, hey, how many times actually call the LLM, or how many times call A2, B2, C2 in a loop. So that's why you need to find the actual function calling and LLM communication in the logs.
Yeah, you can actually ask it to, what steps did you take and what tools did you use, and it'll kind of show you. I use like the read graph to understand that's the API for getting access to its long-term memory, extracting information, and planning the lunchtime. But again, no Slack was used here, so we want to add that capability. So that's what I was just doing here. So I'm going to just bring the Slack service back in. And I mentioned observability. That's a really important aspect for, in production, is to have that capability. So Quarkus has that built in. So I'm going to uncomment out that to give it a pointer to what I'm doing here. And you'll see what happens here. One other thing that I need to do is tell it that it has access to Slack. So I have a little paragraph about each tool. So again, I'm going to just paste in some text to tell it that it has access to Slack. So I have this pre-created text here. Much like what you see already. So I'm just going to paste it in here.
Just FYI, the system message annotation in Quarkus, and it came from LangChain4j. It's the first initial message sending to the LLM to define the scope and the primary role of that LLM. In that case, we're gonna, James said, hey, you have this tool, that tool, which means LLM recognize, oh, I have like a 6 and 5 tool, like including Slack, which I can use.
And last thing I have to do is give it my API key for Slack. It's a bot token and a team ID, so it knows where it can post. With that all done, I'm gonna go ahead and restart the application so that it can bring up an entire new stack of observability. So it's going to start up the LGTM stack, which is Loki, Grafana, Tempo, and Prometheus, which will enable my application to both record telemetry, metrics, things like how much money have I spent on my LLM costs, to what is a stack trace, or what does the call trace look like for one of these very heavyweight calls to an LLM, where it's actually reasoning about its environment, deciding which tools to call, making those tool calls, and then producing the result. That takes multiple round trips back and forth to the LLM, because the LLM is not calling my MCP servers, it's my application calling it, which also gives me the ability to add things like guardrails to make sure that the output is safe, or the output doesn't give a refund that's too large or above a threshold that I want to set. So those services are starting in the background automatically in a container running on my system here. This is a Podman desktop. This is the container that started, and you can see if I look at the logs, it's just starting all these services for me automatically in my container, and then wiring those automatically to my application through auto configuration. So with this stack, I have the ability to look at traces and logs locally. Of course, you'll want to do this in production with your own observability stack, and Quarkus has support for a number of different stacks, including OpenTelemetry. So if you're using things like any of the tracing systems out there, or any of the telemetry systems out there, it's more than likely going to be supported for you. So now with my application back up and running, I should also have the ability to do Slack. So let me just go ahead and give it that prompt again. So let me just copy and paste it in, and we'll see what we get here. I can scroll properly. Here we go. So same prompt. And we'll see what happens here. As you can see in the background, it's again churning away, calling different tools. These are the actual HTTP posts that are being sent to GPT. So if you want to get really in depth, you can check it out. So it found a couple of restaurants. So notice it found several gluten-free restaurants here in Atlanta. So I'm going to say, okay, I want to go with Oku. Okay, let's go with Oku. Please let the team know on Slack. And now it's going to hopefully use the Slack tool. I've notified the Slack team. So if I switch over to Slack here, I should have a new message. Yep, indeed. Is this the one? Yeah, this is the one right here. So yeah, so it sent that message to Slack using that new tool, that new superpower that I gave it. You can ask it other things, like, let me do a few more, and then we're going to show the observability stack. Let's see. One of the things I asked it was to create a calendar entry. There are MCP, like Google Calendar servers. You can also just have it create a file, which is what I did, which is what I asked for. And you'll notice it didn't, here in my prompt, I said create an ICS format, a calendar file. It did not create that file. This is one of the challenges that we face with working with LLMs is there are some that are better than others. With a large set of tools and a large prompt and essentially a large context for the LLM, in some cases it's not a powerful enough LLM to do that, but it does realize that it missed it. So if I can say, why didn't you create this file? And so now it's created the file. So now it's in my playground. If I switch over back to my playground here, I can find it under playground and Oku visit.ics. So I was able to create that ICS file. It would have been nice if it created the first time. Again, with more powerful LLMs that probably cost more money, you can get better results here. But yeah, so let's see. Last thing, what was the reasoning used to find this restaurant? And so you can kind of see some of the underlying things that it thought about. So identify the type of cuisine, it looked up the location context, knew how to, or decided it was going to use local search tools, and then evaluating those options based on the rating of the restaurant, calculating a distance and so forth, and it kind of gives you more information about what it was doing here. So this is kind of cool to see, and you can also look at the actual logs here, but these are pretty huge. I mean, it's no fun to look through this, so that's why we have our observability stack. So Let me show you that real quick, and then we'll switch over to Daniel. So in my Quarkus application, as I'm running in dev mode, one of the cool things you get with Quarkus is a dev UI. So if I simply click D in the terminal here, it's going to open up this dev UI. And this is something that comes with every Quarkus application. Do you have a question?
Yeah, I was just wondering, is there a way you can tell if the MCP server was executed other than going through the telemetry, like programmatically, can you say, did you call these things?
Programmatically, can you say that? Yes, you can, because when, well, actually, that's a really good question. I don't think that the Quarkus MCP server exposes like a hook to allow you to intercept a call to a tool. One of the nice things about Quarkus and MCP is it auto-generates the tool bindings, but I don't think there's a way to intercept those other than looking in the log files. Yeah, that's a good question. That's a good RFE.
Yeah, based on the configuration model, so you're going to set up the configuration, it automatically white it out, and rather than the programmatically some implementation.
Yeah.
So LangGraph would do that, right? That automating the tasks completely end-to-end?
Yeah. You mean LangChain or LangGraph? I have not used LangGraph, so I don't know if it would automate all of that or not. Okay, so in the world of Quarkus, this dev UI shows you all the extensions that I've installed. So all the LangChain extensions are here. We also have the observability extension that I installed, which deployed that entire stack. So I can open up the Grafana UI. It gives me access to all of those, all of the traces and telemetry and metrics about my application. So if I, let's see, where is it? Dashboards. Yeah, so dashboards. Actually, I want to do metrics first. Explore, metrics. So you can see all the metrics that I get basically for free, right? I can show you the GenAI client estimated cost total. So it bases this cost total based on the output from GPT itself, telling you how many tokens it used and things like that. And so over time, this would, you can trace this, you can set up alerts and all the things that you would normally be able to do with Prometheus and Grafana. There's also standard stuff like the HTTP server information, JVM statistics about heap use and things like that. So it's kind of nice that it kind of automatically exports all that, not just the JVM stuff, but also the AI-specific stuff, like the GenAI usage. So like average number of tokens and things like that, how long each request took. So that's pretty cool. And the other thing that you get with this is the log files and the stack trace, or the, I keep saying stack traces, the call traces. So if you have it over to, let me go back here to, let's see, where is it? I think it's under Explore, and instead of doing Prometheus, we'll do Tempo, or yeah, Tempo. So Tempo will show me the different traces that occurred when I was making those LLM calls. So you can see this one here, 3.39 seconds. This was probably the last one that I did. Let me see a more interesting one, maybe 6 seconds. Yeah, this one kind of shows you that there were multiple LLM calls here. You don't know that. That's one RFE I'm looking to do, is to expose the actual tool calls as specific spans with a name instead of this random number. But this is one of the spans here. And you can see the multiple calls to post/chat. I'm see if I can make this a little bit easier to see here. But these were the completion calls to GPT. Multiple GPT calls chained because it was trying to, it was actually calling multiple different tools and getting a response and then sending that back to the LLM and over and over again until it was able to complete the actual prompt. So if I look at one of these, you can kind of look down in here, you can look at the logs for the span. If you look at the span of attributes and resource attributes, you can kind of tell that it's a tool call, but if you look at the logs, it's actually even more obvious because you see the content in here. But again, this is not for the faint of heart in terms of like the content, but you can see here's the prompt to the LLM, and it's sending tool call content in here along with the LLM. So this was one of the tool calls where it got the list of 45 best gluten-free restaurants in Atlanta, sent that back to the LLM, asking it to evaluate based on the star rating of the restaurant, what the best restaurant to choose. So this is the content that the LLM is seeing, and you can see that in the kind of the stack trace or the call trace. Yes,
yep.
Question.
Do you have a span Java and you're calling Python, can the span record or preserve the trace in the
Yeah, I think that is what it's doing. That's why it's, if I can go back, that's why you see the, where is it? Here. Yeah, so these individual traces, these are all associated with the span because they're sort of hierarchical in nature here. You can see it kind of goes deeper and deeper and deeper. So each of these calls is preserving that span ID.
So the trace is preserved across the span.
Yes, for a given, for a single like
Even though it's
completion call.
different apps, different kind of apps, like your Java and
Yeah, different kind of apps. That's one of the great things about MCP. It doesn't have to be a Java. Now, if you want to trace within the MCP server, that's a different story because essentially it's a separate process running on the operating system, right? If you saw in the application properties here, it's actually invoking the npm command, npm exec, and so you can actually see those processes running here. No, there's no process here. So it's a separate process. So that MCP server is not going to be sending back trace and span information in the call because the MCP protocol doesn't have that as part of its protocol. So it's communicating with this other process through that MCP protocol. It's not a direct Java JVM process. Yeah.
So in one of these interactions, did you ever have a feature like a user feedback, like implicit and explicit user feedback loop? Do you have any kind of such? Because you have a chatbot which has a lot of user interaction, but I want to have some kind of user feedback loop.
So the question is there a way to have a user feedback loop?
Yes.
Like where the user tells the LLM that this response isn't good enough?
Thumbs up and down and
Sure, you could. You could have a user feedback loop. That loop would essentially write into the memory of the agentic application, saying that this kind of a response was rated this particular way, so the LLM could reason with that user feedback in future responses. I've not tried that. Yes, question.
May sound like dumb, but I'm going to ask it anyway.
No dumb questions.
So MCP server itself is not the agentic AI application.
Correct.
That's
Yep.
right.
You write your application, which is agentic AI because it is using the MCP.
It is using capabilities in MCP that agentic apps need, things like tools and memory.
Yeah.
Yes.
So basically, all AI agents need data sources, right?
Yes.
Like to write, to have the memory to remember.
To be able to do more than just a general LLM prompt response, you need it.
LLM is just like, hey, here's
Yeah.
the question, give me an answer.
Yeah,
right?
that's correct. Yeah.
So MCP abstracts all that in like other
Yes.
infrastructural issues which coders may need to code
Yeah.
and allows developers to just focus on what they really want.
Yes. So MCP, so I'll put it this way, MCP is like an abstraction that lets developers expose their services in a way that's friendly to agentic AI applications. So the application is a Quarkus application. There is no main method here. This is not a workflow. This is completely declarative. I declare the LLMs I have, I ask it questions, and I allow it to make decisions about what to do, and I give it superpowers with these tools through MCP. So you don't have to use MCP to build an agentic application.
No, I get it.
Yeah.
I was just trying to not draw conclusions, but figure out what,
Yeah.
where does this MCP server or the architecture fits in the agentic app.
Yes, got it. Yes.
So would this be kind of like a star architecture where MCP is in the center and you have all the
Yes, in many cases it's like a star architecture. Yeah, that's right. And that's what we have here in this demo.
Quick question, is everything running here, is it local on your computer?
It's all local on this laptop right now, except for GPT itself. Yeah, now you can run out local LLMs. I actually tried with like Llama. The results weren't good. So if you look at the log, actually, let me see if I can find one real quick. I'm sorry, Daniel, I know you have a demo. So when it passed that, let's see if I can get to the beginning of this one. So, okay, so here's one of the calls. So it's a post, HTTP post to OpenAPI with the prompt that I set up in my Java application. It also then gives a list of tools. And this is actually the results of tools, but it is also, if I scroll down here, this is the list of tools that it has available to it. If I scroll, where is it? Here. So this tools array is a list of tools, and there's a lot of them, right? When you add an MCP server to your application, it can export like 50 tools, individual endpoints. So there's a Brave Web Search endpoint. Here's a Brave Local Search endpoint. Here's the tool for creating entities in the long-term memory. So on and on and on. So there's probably, I don't know how many there are. There's probably 50 tools. And so the number of tools you pass through an LLM, the more complex the query. Small models running locally, like a Llama 328B, is probably not going to be able to handle that number of tools. So the LLM, you give the LLM a set of tools with an English description, and then you give the LLM a query. You're saying, I want to set up a lunch next week. So from that query, it is able to discern that, okay, I have a tool that lets me do web search. I'm probably going to need to do that. And so it responds to you saying, hey, I need to do a web search with this query. Then your application, in this case Quarkus, is responsible for calling that MCP server and using the protocol to do that web search and then provide the results back to the LLM in another query, another prompt. So it's like a back and forth between the LLM and your application.
Basically, the agent decides based on the tool set you have provided.
Correct.
What tool it wants to invoke.
Yep, and so you can see this particular tool has an English description, and so an LLM, a good LLM is gonna have this and know that, okay, I need to get some file off. I need to get a file off the file system. I have this thing called get file info. I should probably call that because of this description. So, and this is true of any application. This has nothing to do with Spring or Quarkus or anything else. This is the way function or tool calling works in the world of LLM.
Who's making the decision that you need to go to Brave Search? Is that LLM?
That's the LLM, yep, the LLM is making that decision, but it can't call Brave Search directly. All it can say is, hey, I need to call Brave Search, please do it for me, and then give me the results of that, and then I will continue on my reasoning about what to call next.
So can you show the source code for, I guess, the Agentic AI part of this?
There is none, that's the magic, right? So I'm declaring that I have a LLM that I can use in my application with this. This is the prompt that should be sent as a system message. There is no source code to actually make that call. This is why Quarkus and LangChain4j do it automatically for me. So you remember that post I saw, the HTTP post? There's a bunch of other junk that you have to pass to OpenAI. I didn't have to program any of that, right? That's all just, it comes with part of the LangChain4j integration with Quarkus.
So essentially, your application is a set of these tools.
Yes.
In the LLM.
A set of these tools in an LLM, that's it. That's why it's so cool. There's like, this is really the only two source code bits I have. I have the declaration of my AI service, and I have my WebSocket, which is super short.
But I guess, would you say that the next evolution of this, like if you're building an enterprise level tool, and you have to influence the logic of the AI, would you be coding at that point?
Yeah, so the question is, if in the next evolution, if you want to include logic, like business logic around the AI, yes, you would be coding that. That would turn it into less of an autonomous agent, more of a workflow, where you can like have a sequence of predefined steps that you go through. Those steps might use an LLM, but you are programming the steps to take, as opposed to letting the AI LLM decide for you. In that case, you would probably have a main method or some other set of imperative steps written in Java.
Like, for example, you would send all the tools to LLM at any given time, right? You might say, only use these tools for this step.
Yeah, you could do that. Yeah, you could programatize this and limit the number of tools that the LLM sees. Absolutely. But again, you're sort of taking away some of the superpower, but you're also gaining control. Yes, question.
So is MCP also coding the tools, or is it LangChain which is coding the tools?
The question is it MCP or LangChain coding the tools? So it is MCP. So let me show you something real quick. We're almost out of time. Yeah, if you look at the source code to this MCP server, it's really simple. It's like it knows about the Google or the Brave Search API, and it has some back-end web client calls to that Brave Search, and then exposes that through the Brave Search API. But yeah, the server itself, each MCP server has specific logic for that service, and it knows how to call Brave Search, it knows how to call Slack and post a message in Slack and things like that.
But what if you want to build the tools? Like,
You can build your own tool. In fact, you can do it in Quarkus. There's an MCP server extension in Quarkus that makes it super simple to build a tool in Java, which is one of the great things that we love about it. It's because it almost brings the power of the traditional AI world with Python to Java developers. So, okay, so that was it for the observability. So I'm real quick, Dan. I don't know if you can do 5 minutes or not, but he's going to show you how to scaffold this, right? Because this is all locally running. This is basically a demo. If you want to get this in production, it's going to require a bit more. So I'm going to hand the thing back to Dan for 5 minutes.
But it's great questions.
Yeah, really good questions.
All right. I just quickly search for rank chain, rank graph stuff. They're actually not configuration model like a Quarkus, but rank chain. Rank graph also MCP integration, but you have to create a Python for like a wrapping stuff, just like this diagram. Anyway, so second demo. So James showed how the developer actually develop a Agentic application with the Java, Quarkus, and MCP stuff. And now you're going to scale that capability across your team. How do I do that? Is a Quarkus basically create like a software template in the Backstage. Backstage is kind of internal developer portal. So internal developer portal, you can go there like a website, and then you can find all software template, which is automatically fork your like a Git repo on your account, and then you can have your IDE tool, and you can have a build, deploy to all kinds of stuff for your dev environment. You will have that thing. That's the internal developer portal or documentation, API specification like a Swagger UI. All thing you need to for application developer will be there. AI application will be same. But how do you expose your existing application for that software template rather than creating something from scratch? So Quarkus provides some the extension. Just create a new Quarkus application. I'm going to go to Quarkus app, and then this is very simple application. You can have, let's say this is your Quarkus application, and then I don't have any the software template Backstage stuff. It's Backstage is one of the CNCF project to stand up your internal developer portal. So, and then I'm going to just add Quarkus extension. I'm going to try to add the Quarkus, the Backstage extension. I'm going to try to add on, and then it will automatically generate like a Backstage configuration in your Java project soon enough. And in the meantime, if I go to application property and then try to add some Backstage, some template generation, I'm going to make it true. And also, I need to install some developer services as well for my verification, dev services, and like a dev template, and let's say installation. So that's the, and then I'm going to use the Java 23 right now. I'm going to change that. I'm going to try to run the Quarkus step. And when I run the Quarkus step, it automatically build my application based on my local directory. And then it will automatically generate a Backstage, like all skeleton project. So default Quarkus Backstage, one of the sample example software template, I just add the dev template. And now you can go to like a skeleton, which is exactly from my application, like a greeting source or something like that. And the catalog info, this is all YAML file. It's deployed to Kubernetes for standard internal developer portal, which include all kind of stuff. And then they are using like a more integration in production, like a Helm chart or GitOps, Argo CD, and the CI/CD pipeline, like a Tecton or Jenkins, and then like a ID tool and so on. So let me try to go to Dev UI as well. So this is also running on Backstage as the test container, as AKA Dev Services. Podman. So you gotta have a bunch of stuff, and then go to probably here Backstage. and then go to random user. Sometimes it takes some time to rendering the stuff. In the meantime, I already created exactly same agentic application with a multiple infrastructure integration into Kubernetes. Just James showed that. This is my Kubernetes cluster in the backstage, more like a fancy way. This is I created from that practice from my local, and then created that kind of stuff. Oh, this is my user application, like an agent app number 2, and then this is my Maven, like a parameter group ID artifact ID. I'm going to use containerize this application and push it into some container registry. You can see any container registry, and what kind of model you're going to use for this agentic application. For example, James used GPT-4o mini, so I'm going to use the same thing. And then what kind of MCP server you're going to use that? So let me try to use pretty much the same thing, like a Brave search, and then like a time, and Google Map, and memory, and Slack, whatever day, and then just, this is my local GitLab, which is another Git repo running on container on top of the Kubernetes just for me. And then once it's just create a new software template for my workspace on the cloud, and then it automatically try to build something my application, like just copy and clone the original Git repo, the agentic application. So James already pushed it to somewhere central Git repo. For me, I just pulling down with some this kind of old software template. It will trigger soon enough to start the application build, like a Maven build, and then deploy into Kubernetes. And then in the end, I'm gonna access the same agentic application on the cloud.
And one important aspect to this, so basically what Daniel's showing you is the ability to expose a agentic AI application template to your developers, so they can choose which servers, which tools they want, which other capabilities of MCP, and then generate a new application that they can then work on in their local workspace. And so it's a very powerful way to make a generalized AI agentic application that you can then pick the model, you can pick the MCP servers, and then each developer, depending on their use case, can pick different capabilities that they need.
That's all excellent. So as you can see, this is my dev environment, dev UI. As you can see, I just created software template, pretty much simple from my Scaffolding project. And you can see it's pretty much simple. Oh, what is your component ID? And the project detail for my Maven project could be Gradle. And then once I just review my software template, I just create that thing. So this is a very simple from. And then I really take some more time to apply for the James, the static application, with more like a real infrastructure integration. That's you can so back to here. I just clone the project, as you can see in the logs, and then it will take some time, like a build Java application, like a job file, as well as a containerized application, like you create a container image and then push that container image somewhere. Containers, like a private container, in this case, like a query, and then it will deploy to some available Kubernetes node, and then I'm gonna get to there, and I will see the same front-end application in the end. So this is really some important part. Whenever you create a new agentic application, you probably want to share that agentic application with your team member, and then they just download and use that from there. And then pretty much easier, yeah.
We should fast forward to the end. We're way over time.
Yeah.
Last slide, summary slide.
Yeah. Okay, so thanks for joining today.
No, we have the actual, you don't have the slide deck up.
All right, we have just one summary from here. So there are a few great roadmap in MCP. So currently we use like a sub-processor in laptop, right?
Yeah.
But in the next couple of months, there are remote MCP support, like externally MCP support running on that. And then it's more support, more advanced agentic architecture. Like James mentioned some of the agent design pattern, such like a hierarchical or interactive workflow or multi-agent stuff. And also support like a stateless agentic application. Just an example, I'm going to deploy my agentic application serverless. serverless architecture, which means these are totally stateless. In this case, Agentic app also support that, and then more like a vendor and an open source ecosystem, just participate in the MCP project, and then develop more the server side and the integration side, and so on. So we have 3 takeaway today. So Agentic app, that's super complicated, and then not easy, and then a lot of effort, time consuming stuff. And then even if you finish that job, it's pretty much not easy to scale this kind of agentic stuff with your team and the shareable and then more cloud native way. So luckily we have today Quarkus LangChain for Zen and MCP integration, which enable an accelerated agentic AI application development experience, less code, and then more productivity. Any other?
Nope, that's it. Thank you for coming. I know we're way over time.
I'm gonna go switch back to last one. Oh yeah, we got just finished. And then I'm gonna go ahead my Quarkus app here. And now, ta-da, we have the same application on the cloud.
Yeah, maybe, yeah, maybe with a different model or a different set of MCP servers. So
Yeah.
very powerful.
Thank you so much.
Yeah, if any questions, we'll hear. It's a break now, so